So welcome, everyone. Welcome to VW MOOC 25 and today's session. And we're really excited about this. Thank you for joining us. Feel free to use the emicons and show how happy you are by using everything in Zoom. And you may use the chat at the end of the session. Everyone will get a certificate of attendance. And of course, the presenters will get their presentation certificate. So a little bit about our presenters who are both coming to us from Mexico. And that's Dr. Christian Jonathan, Angel Rueda, Martin Yahun, Aguilar, Muñoz, my terrible pronunciation, sorry about that. So Martin is a graduate student at the Universidad in programming and programming professor at another university, where he also completed his undergraduate degree. He's passionate about working with virtual worlds and focuses on educational innovation through immersive technologies. As a software engineer at Trem Vet, with experience as a research journal coordinator, his research project develops a didactic strategy for teaching programming fundamentals using interoperable and multimodal virtual worlds. Through qualitative action research methodology, he aims to create a validated framework that integrates three-dimensional immersive digital environments into programming instruction, addressing the challenges he observes in teaching abstract programming concepts while leveraging available virtual reality resources to transform the educational experience. And Dr. Christian Jonathan Angel Rueda has a Doctor of Educational Technology and is a doctoral scholar. He graduated with honors for the thesis Designing a Didactic Model to Introduce Teachers to the Use of Virtual Worlds for Educational Purposes. He holds a master's in administration and consulting and a bachelor's degree in design and visual communication, and a specialization in educational research with honors. He's a postdoctoral researcher focusing on inclusive teaching in immersive 3D digital environments. He's a member of the Mexico's National System of Researchers, speaker at global events, including Virtual Educa, and you can see the rest, as well as in ASJ Japan. He published on AI, ethics, virtual worlds, 3D immersive digital environments, and XR-based education. And you can find his publications by Googling Google Scholar for more. So we're really thrilled to have you with us, and we can't wait to hear about this innovative way to teach programming.
Well, hello everyone. I will just present about my research. Well, the thing I have to explain is that I'm doing my master in a university. The thing here is that I'm working with the Dr. Christian because I'm the student and the person that have the knowledge is the Dr. Christian, and he's teaching me how to make research, how we can make something in the virtual reality, things like that. And my topic is teaching programming fundamentals in multimodal virtual worlds. The thing here is that my research emerged from a critical challenge we face not only in some universities. We work in the Universidad Politécnica de Santa Rosa, Jáuregui, but we only don't work in this university. We work in other university, but we see that there are some problems when we are talking about the programming because we made that our investigation has been conducted by another programming from another university that is Mievia, that is from Universidad Autónoma de Querétaro. The thing here is that we are teacher from the software engineer, robotic computational robotics, and other careers. The thing here is that we see that some students don't see really how the programming works. They understand how is a iteration, how they can code, things like that, but don't process how really is working the programming. That is the we can say a question: how might we develop a comprehensive teaching strategy for programming fundamentals within an interoperable and multimodal virtual worlds to transform educational outcomes? Because we don't only to make a virtual world or where you can only play a video game or something that is only to play. We want to make something better where the new technologies like the AI bring some new tools to improve the education inside the classroom, something like that. And we change the light. The second slide. Challenging programming educational and the UPERS RJ, we can say that university where I focus my research. Let me begin by outlining the specific challenge we have identified at UPERS RJ, which reflect broader system issues in programming education. The scale of the challenge of research has revealed that high failure and drops rates in introductory program. I sorry if I stop because I'm reading the comments. So affect the student success with a study 50% failure and drop rate. The problem here is that if we have around 30 or 40 students in a classroom, only 3 or 4 of them really like programming. Most of them only is there. Well, in Mexico, in the context that we are, they only go to the university to get the paper that can give you the title or thing like that. That could be different in some other states, countries, things like that. In the university that we are working, most of the students only go because their fathers say you have to go to get a career, and they choose. I think so. They believe that programming is more easy than others because they say I'm always in the computer programming and I'm writing code. But programming is not only write code. We have to do more things that at the end the thing that we must do is to process how the programming works. We don't have to learn all of the documents, all of the repositories in GitHub. We don't have to learn all about the program, but we have to process what we are doing when we program. Other challenge is the faculty pedagogical. The faculty consistent finds difficult teaching abstract programming concepts such as recursion and algorithms. Traditional teaching methods often leave both educators and students struggling with concepts that lack tangible. The thing here is that we want to represent in a visual form the programming structures, the programming things that they can see or they can compare to the things like they see in the real life. For example, if we're making a sandwich, we can say that is something that we can do in programming because we are repeating um, action, or we can do the same thing 2, 3, 4, 5 times more than only one. Another, we are working with the VR resources. The thing here that becomes that is part of the world of the Dr. Christian. He showed me the world of the virtual world, the reality, bueno, the virtual reality, the augmented reality. Because before working with the Dr. Christian, I don't use it never these tools. But when I start to work with him, I see that there are a lot of another word that we can work with the technology that is immersive. We're working with Second Life, Tansar, Roblox, Rec Room, and a lot of tools that let us to make projects. The most interesting that I find is that we're working with the extensive reality that we can make the turn off or turn on light. But since Roblox, we all can click a button in Roblox and turn on the lights, open doors, move robotic parts, things like that. And the most critical point is we have a gap that exists between advanced technology and lack of valid didactic models for edit integration. Well, in Mexico, we do the things in the traditional way. Why? Because most of the teachers, well, for example, me, um, that I know more about programming, about the technological system, I work with, well, we always work with Office, Word, PowerPoint, Excel, but I have around 5 years that I don't use Word, PowerPoint. I use other option that is from free code, for example, like OpenOffice, things like that. We don't have to use or don't open our mind to other tools because we are working with only one. We have to see the other options that we have in internet, in repository, or also we can make our own tools because we have the AI that can help us to make more easy to develop something like that. And sorry because for me it's a little difficult to speak a lot of English because I practice my English, but it's a lot of time with speaking English. So that's why I'm some troubles in my pronunciation. The literature review and the theoretical foundations. Well, our approach building upon several converging research string that validate the transforming potential of immersive educational technologies. The point one is increased use of immersive technologies. López Lorzano and Ángel Rueda, the Dr. Christian that is here, and this is the 16 study release increase of use of immersive technologies in education documented by research studies. Their research highlight the growing importance and adoption of this approach. The evidence of that virtual reality shows a moderate positive effect on developing practical skills. The digital competence among Latin American professors are perceived as inadequate, and constructivism and interoperable framework underpin effective digital learnings. All of these things is the part from I start to make my research to show how we can improve the way that we can learn programming. I will change to the next. The basis of my research is that develop a didactic strategy for programming fundamentals, identify essential didactic requirements, design a strategy transforming programming learning, implement strategy with faculty participation, and evaluate my strategy effectiveness as the UPERS-RJ, that is the university where we are working, and focus on immersive and multimodal experience in a virtual world where we can person from of parts of the world can work together and there's a collaborative improving inside the class. I will change it. Research questions on virtual teaching strategies. I have 5 points. The first point is effect of interoperable virtual environments on pedagogical strategies, impact of multimodal environments on faculty collaboration, increasing didactic capacity among faculty users, faculty perceptions of utility and effectiveness, and the difference between virtual and traditional teaching strategies because there are all of teachers that work in the traditional way in the university that is in our context that is here in Querétaro, for example, that they don't want to use new tools that they can find or they can use it to improve how they teach some topics and things like that, and they are doing it the traditional way. The qualitative action research methodology. The action research approach, the methodology follows a qualitative action research framework emphasizing a reflective process to improve community educational practice, as online by Peralta Castro and Mayora Valdivia. The faculty participation that we asked to the university to give of the pedagogical transformation and the resources to make the research that can show the reflection and improvement in teaching methods with engineers programs, that is the software engineer or the robotic computational engineer. Sample selection, in the university, we are not a lot of teachers. I'm one of them. There are around, but in this moment, when I write the methodology, there are 6 to 8 teachers, but now there are around 3 or 4 programming teachers for all the career, and that can make that only can implement my research in only that little group or person to see, well, it's not to see if we can improve the education, but is to show we can work together to make a we work to virtual worlds to improve how we can teach programming. Example. For virtual world implementation integrates multiple platforms and space to create comprehensive immersive learning experience that address diverse pedagogical needs, the virtual spaces, and the technology platforms. The virtual space architecture, we have designed a comprehensive framework incorporating virtual classroom for traditional instruction within immersive contexts. That we have the virtual classroom, the practical labs, collaboration spaces, visualization areas, and evaluation zones where they can work or learn something new, and we can evaluate them to see if there are some changes how they understand the topics. And the technology platform, we can say that we have the primary platform that could be the virtual board, Roblox, Second Life, Sansa, Rec Room, all of the tools that we can find in internet, the portfolio management, the meeting platform, and the analysis software. How I can say this? The portfolio is to document everything that we make with the research because it's not to improve something. Instead of that, it's how we can work together to show the programming to all people if they're in a engineer, the programming or not, they can learn how the programming works. We can make meeting in a meeting platform where they can talk together to see what can change, what can improve, something like that, and how we analyze the results of that. Well, the results of all research. This instrument for data collection, I will use semi-instructor interviews, digital field diary, observation rubrics, focus groups, and digital portfolio. The things here is this multiple instrument approach ensure triangulation of finding whitelists, capturing both individual and collective dimension of educational change. The combination provides robust evidence for virtual teaching, effectiveness, and sustainable implementation strategies. We use all of these tools to get the information to can apply the research and how we can get the results. And the action research cycle in educational development, planning the fundamentation design, the action phase implemented training and practice, the observation phase monitors interaction closely, reflection phase evaluates an improvement, iterative development ensures continuous refinement. If faculty needs diagnosis guides content relevance. All of the steps that we can see in the research is how we can improve, but it's in a circle where we are doing one step, another step. We are working to improve how use the virtual world, the virtual reality, the augmented reality to teach programming. And I could say that it was most of the is a review of all of my research. I wonder if the Dr. Christian can continue with our evaluation methods and institutional impact analysis, please.
Thank you, Martin. Good morning, college. As a thesis supervisor, I discuss the rigorous evaluation framework that ensures this research generates both theoretical insights and practical improvements in programming education. Okay, our assessment framework for adopting development and qualitative insights exploits six interconnected evaluation dimensions, each capturing distinct aspects of educational transforming. Measure comprehensive level. We develop the depth of understanding by categorizing learned knowledge into basic, intermediate, and advanced stage to track adopting fitness. This systematic categorization allows us to measure how virtual environments facilitate conceptual progression in programming fundamentals. Track gradual implementation. If you look in the presentation, we monitor the incremental integration of specific teaching strategic components to assess the practical adoption rate within the instructional settings. This dimension captures how faculty progressively incorporate virtual elements, Ident- identifying barriers of facilitators to sustainable implementation. Then we look the assess competitive evolution. We compare technological skills prior to and following training to determine professional growth and skills and change among the educators. These before and after assessments provide concrete evidence of faculty development through virtual teaching experiences. Evaluate method diversification. We identify the extent to which educators adopt diverse didactic methods, reflecting adaptability and enrichment of pedagogical approaches. Through virtual platform integration, these assessments examine where immersive environments foster pedagogical innovation and flexibility. But when we analyze utility perception and user experiences, we gather qualified feedback on the practical value and usability of virtual environments to optimize the learning experiences for users. This analysis ensures that technological solutions address genuine pedagogical needs rather than imposing artificial complexity. Measure problem solving application. This point is so important. We will let how effectively techniques and strategy are used to address particular pedagogical issues encouraged by educator. This dimension ensures our virtual solution provide practical value in resolving authentic instructional challenges. This comprehension of this framework, ensures that evaluation captures both quantitative improvements and quality transformations in programming education. Please change the next slide, please. Okay, this is important to connect with the last slide. Expect outcomes and institution applications. This is for our University of Politécnica of Santa Rosa. This research will generate tangible results and practical educational impacts through systematic deliverables and strategic institutional applications. What it means that primarily deliverables our research produced for essential outcomes. Didactic strategic document provides a comprehensive framework for virtual programming educational. Faculty implementation manuals offers practical guidance for educators to adopting immersive approaches. Methodological guides by edit these three-dimensional immersive digital environments, deliver evidence-based protocols for systematic technologies integrating and validate assessment instruments, supplies reliable tools for measuring virtual learning effectiveness. Okay, then in this institutional application in the University of Politécnica of Santa Rosa, the research enabled for strategic institutional improvement. The Tramberg Lab optimization is a lab that we have here in this university, ensures direct enchantment of our virtual learning laboratory facilities, replicates subject model, create templates for extended virtual approachments across engineer disciplines, faculty development frameworks, establish systematic professional development programs for immersive pedagogy. Look, immersive pedagogy and communicate of practice building sustainable networks for ongoing pedagogical innovation. The strategic significance in this situation, let me see, these outcomes address the persistent innovation practice gap in programming education by developing evidence-based strategies. We create sustainable bridge between educational technology and potential classroom reality, ensuring that the virtual learning environments deliver measurable improvements in both teaching effectiveness and student outcomes. Okay? And the institutional application ensures that research finds translate into systematic educational transforming rather than isolate technical experiments. Please, the next slide, please. Innovation and practical significance. The research addressed critical needs in programming educational through evidence-based strategies for engaged teaching outcomes that bridge academic involving with practical implementation. First important thing we have to understand in this research. The academic innovation dimension is our approach advanced with 5 key areas, like will be bridging technology and pedagogy that creates systematic connection between immersive technologies and educational effectiveness. Then evidence-based with framework ensures all strategies are grounded in rigorous research methodologies, focus on programming challenges, address specific difficulties in abstract concept instruction, interoperability emphasis. Interoperability emphasis is important. Enable integration across diverse technologies platforms and the multimodal teaching methods that incorporate multiple sensory learning pathways. This is the complex of these virtual worlds. And in the practical implementation impact, the research generated 5 concrete improvements, reducing dropout rates directly addressed to the 50 failure rate in introductory programming courses, and changing faculty skills provides systematical professional development for virtual teaching competencies. Immersive students engage creates learning environments that make abstract concepts tangible and manipulable. In this case, sustainable teaching transformation ensures long-term with pedagogical improvement rather than temporary technology adaptation and improve learning outcomes. Deliver, measure, and change in students' understanding and retention. Then, finishing this slide, we can systematic education transformation. What is that? This dual focus on academic rigor and practical application ensures that virtual programming educational becomes a sustainable institutional practice rather than an experimental initiative. The framework balance innovation with a practicality, creating scalable solutions for programming and educational challenge. The research established virtual learning as a valid pedagogical approach backed by a systematic evidence and practical implementation strategies. The next slide, please. Um, project timeline and progress overview. This is the well. Here is we have the last year the literature review phase. Martin have a good part of that. Then the methodology definition phase in the between the last year and this year. The definition methods and collective data. Then in the last months, data analyze phase, analyze data and development results. And then, well, right now, current status and progress. We have successfully complete the literary review phase, establishing robust theoretical foundations, and the methodology definition phase in progressing systematically with research instruments finalized and virtual environment designs completed right now. Data collection protocol are established and ready for implementation in the upcoming phase. This systematic progression ensures that each research phase building upon previous finding whilst maintaining methodological rigor and practical relevance. Okay, this is right now we are connecting that places right now. Okay, the next slide, please.
We are there, doctor. I
Okay,
changed to show all of the timeline.
okay, perfect. Um, in the 14, okay, part two. Uh, the remaining phase of our research timeline focus on framework refinement, strategy testing, and thesis complementation. Well, this is important for me because I have to understand how is my student right now, and the framework revision phase, like from April and June, will revise frameworks and implementation virtual roles based on initial data analyzing findings. This phase involves refining virtual environments, adjusting in the pedagogical strategy, and optimizing technical implementation based on empirical evidence from early testing phases. Uh, from July to December, we are trying to make a strategy testing phase. We will test and evaluate teaching strategies through systematic implementation with participants, faculty members. This extended testing phase allows for a comprehensive evaluation of virtual teaching effectiveness, faculty adaptation progress, and student learning outcomes across multiple programming courses. Not one, multiple, okay? Uh, well, in this case, Martin have different classes and other professors or not only have one class. And important is how this connect with these classes. Thesis complementation phase in the next year. We will document finding and finalize the thesis and integrated timeline management. Each phase includes systematic evaluation and adjust mechanism, ensuring that research development remains responsive to empirical findings while maintaining timeline advances. The extended testing phase provides sufficient time for thorough evaluation of virtual teaching strategies, quality assurance throughout regular supervision meetings, peer review progress, and methodological consultation ensure that research quality remains constantly high across of all development phases. And well, all of the things that you are looking in this presentation can help to us to look if we are following this method better. But well, thank you for all your observations. The next slide, please. Well. Challenge and mitigation in of teaching programming fundamentals. Oh my goodness. Well, this is important. Our research, that research of my students, faculty resistance and infrastructure challenge for effective teachings. Look that. Through systematic mitigation strategy that ensure successful implementation, anticipate challenge. We five we have identified four primary implementation challenges. The first was that the faculty resistant to technology adaptation. Well, this is always in the university that don't change her minds of connection with new technologies. Well, here is always the same. Often stems from unfamiliarity with virtual environments and concerns about pedagogical effectiveness. High technical infrastructure requirements may limit institutional adaptation and accessibility. Well, here in Mexico, we have all this situation of high technical infrastructure requirements. But the limited time for comprehensive training, wow, this is so important, constrains faculty development opportunities, and the difficulty in measuring long-term impact on student outcome require sophisticated evaluation approaches. And in this point, mitigation strategy is our systematic mitigation approach address each challenge, implement a gradual approach to adaptation, emphasis in the pedagogical benefits rather than the technologic features, ensuring faculty see educational value for technical complexity. Another point is to be providing continuous support and training through the ongoing professional development and flexible adapting to individual faculty needs. Offer flexible adaptation to faculty needs, recognize diverse technical competencies in a pedagogical preference, and use mixed method evaluation for thorough assessments, combines immediate feedback with longitudinal tracking to capture both short-term adaptation and long-term educational impact. Provide risk management. All these situations have a provide risk management. These mitigation strategies are integrated into our research design rather than a reactive response to problems. By anticipating challenge and developing systematic solution, we ensure research continuity while addressing practical implementation concerns that could undermine virtual teaching adaptation. Okay, and sustainable implementation focus our mitigation approach priorities sustainable long-term adaptation over short-term technological. Okay, demonstrations, ensuring that a virtual programming education becomes institutional embed rather than a temporarily experimental. Okay. Please, the next slide, please. Okay, with this, the thing that we are saying, future research directions. We have important future research directions. This research open extensive opportunities for exploring extension and broader impacts for VR in education. Well, in the different levels of immersion. Third person, conscious immersion, total immersion. Well, we say VR because it's a continuous about the idea of this connection. But across multiple dimensions of educational technology and pedagogical development, The potential extensions, 4K areas you're looking in the slide, offer significant research opportunities. Student outcome measurement involve developing comprehension assessment tools that capture learning and improvements, retention rates, and long-term academic success in programming courses. Scalability across institutions. Examines how virtual teaching strategies can be adapted and implemented across diverse educational contexts with varying resource and technical capabilities. And then cross-disciplinary application. This is so important. Explore extending virtual learning approach beyond programming to mathematics, engineer design, and other abstract concepts domains. Yes, the virtual world we can teach abstract concepts domain depends how on the understanding of these virtual worlds. And the long-term faculty impact investigates sustainable change in teaching practice, professional development, and career satisfaction among the education using virtual environments. With these virtual worlds, I like that. Okay, ahora, the other situation, broader implications. For strategic areas emerge for institutional and policy development. First, educational policy. Considerations include integrating virtual learning standards into curriculum requirements and accreditation process, because if we don't put and understand how virtual worlds can connect with the curriculum, we're bad. Okay? Professional development frameworks establish systematic training programs for virtual teaching and excuse me. Oh, allows something over here. Uh, and the institutional adaptation. Strategies facilitate systematic integration of virtual learning across departments and programs. Okay? Research community contribution. These future directions position broader educational transformation. The systematic approach we would develop creates frameworks that other research can build upon while is practical and adapt for diverse educational contexts. Here is so important for diverse educational context. This is a point important because the diverse educational contexts from different countries are different ways, because we have to understand our countries, our context of how is our educational context and the society, our problems with the connection, with our problem with type. This is why I like these years, because the virtual worlds is not only for one system or for one computer. Right now we can connect virtual worlds with smartphones, tablets, VR, and all these elements connection we can connect in a one virtual world in different levels of immersions. But we have like teachers, because the most important is that the teacher understand the situation. This is why the frameworks can help to understand these macro concepts, these concepts of immersion, this concept of perception, these concepts of how we connect with this technology. But the technology is not the important. The important is the teacher. Okay. Sustainable innovation pipeline. Future research direction ensure that a virtual programming education continues evolving based on empirical evidence and practical experience rather than a technological trends alone. Okay, the next slide, please. We are finishing. Uh, with this slide, we're finishing the conclusion. Engage with transformation challenge. Right now, when I come to the university, I'm talking with the artificial intelligence that I like when I am in my car driving to my school, and the artificial intelligence say to me, Dr. Christian, because it's so respectful for me, I say, I like your ideas and I like that you are trying to come with these virtual worlds and with your students that trying to empowering how the education is the heart of the essentials, because we forgot the essential of education, because we are always looking for new technology when we have to understand the essential of education, because these technologies, immersive technologies, artificial intelligence, and the connection between them are tools to help the teachers. And we have the most important is to understand how to teach, know how to technique of use, because the new technology, a difference from the last technology of is that are so easy to compression. But the difficult important thing is the compression of understand the concepts which different of level of immersion, the perception that the students use with these technologies. And well, excuse me, I am passionate about that, and I try to say to Martin, we have to look these ideas. This research represents a systematic approach to driving transformative program educational change through faculty-centered action research, methodological, and evidence-based virtual learning implementation. Research systematic, we have developed a comprehension of framework, not, not of the great technique. No, we have the comprehension, look this word, framework that address the critical challenge facing programming education. Higher drops rate, faculty pedagogical difficulties, under technological resources, and persistent gap between educational technological potential and classroom practice. Our systematic methodology ensures that virtual learning solutions emerge from authentical educational needs rather than imposed technological solutions. The impulse of technological solution is not the idea. The idea is to have, right now we have many virtual worlds, different type of virtual worlds for different contexts. If we have a low internet, we have virtual worlds that connect with a low internet. If we have a virtual world with multimodal connection, we have rather many. Maybe 50 years ago, we have one important virtual world. Right now, we have a lot of different contexts of tools that when we have a comprehension of these concepts of immersion, of the three-dimensional immersive digital environments, we have the solution. Okay? Methodological contribution. The faculty-centered action research approach treats education as a collaborative partnership in pedagogical transformation, ensuring sustainable adoption and continuous improvement. Our comprehensive evaluation framework captures both quantitative improvements and qualitative transformations. Quality transformation, okay? Provide robust evidence for virtual teaching effectiveness. Institutional impact, the expect outcomes, documented didactic strategies, faculty implementation with manuals, validate assessment instruments and systematic evaluation frameworks. Will really improve programming education in the Politécnica of Santa Rosa while it's providing replicated model for broader institutional adoption. Transformative vision. Our research explore the faculty-centered action research methodology and the potential of virtual worlds to visualize abstract programming concepts, emphasis with systematic implementation for sustainable education transforming. Call to engagement, please. We invite the academic community to engage with this transformation that we are talking about, approach to programming education, recognizing that systematic changes require collaborative effort, evidence-based implementation, and sustained commitment to pedagogical excellence through innovating virtual learning environments in these virtual worlds. Future commitments. The research established foundation for ongoing education innovation, ensuring that virtual programming education continues evolving based on empirical evidence and practical wisdom rather than technical novelty alone. Please make questions, discussions. Welcome to about our methodology, space outcomes. Thank you for your attention and considerations of this research. Thank you. Because it's an important thing, not how to use the technique of the tools and something like that. It's more important the reasoning, the thinking of how to teach. Yeah, I looked at.
Yeah, these are
In
all
that
very
way.
good questions. And I think that action research is probably the best way because of the implementation. It's not just conducting research, but it's applicable. You'll be able to use this not only, as you said, not only with programming, but in other fields as well. So I think this is going to be amazing, and I can't wait when for the results that come in, and hopefully next year you'll be able to present them, or maybe before
Yeah,
that,
no, yeah, the next year we'll be
for sure.
presenting.
Okay,
Yeah, thank you.
so thank you so much once again, Jonathan and Martin, for this, and everyone for joining us.